The ultimate destiny of every single world in our cosmic neighbourhood is permanently bound to the massive star they revolve around. Therefore, when it comes to our local neighbourhood, the Sun completely rules over our ultimate future. As our parent stars shifted over time, the environment required for living things to emerge has shifted across our surrounding worlds too. Looking back at their deep history reveals that a world's habitability is a highly fragile equilibrium, a temporary state of grace that is never guaranteed to endure forever. Out of all the worlds we know, only a single planet has successfully managed to keep its liquid surface water and remain hospitable to life, and that planet is Earth. What is truly astonishing about Earth is the incredible durability of those specific environmental conditions. Our world has somehow kept its liquid oceans intact right on its outer crust through every single era, persisting across multiple billions of years. And it is this exact permanence that has allowed a remarkably diverse and complex biological tapestry to develop and flourish over time. Earth stands out as a truly exceptional sanctuary in the cosmos. It remains the absolute only location in the entire known universe where we have definitive, undeniable proof that living organisms exist. For this miracle to take place, it is not enough for a planet to merely experience liquid water appearing for a brief geological moment. Instead, you need that liquid water to permanently stay on the surface of the world without evaporating or freezing away completely. That is the foundational magic that defines Earth, and we owe it all entirely to the specific physical dimensions and inner geological activity of our world. Our protective blanket of air has stayed remarkably stable for billions of years on end, acting as an essential shield for the invaluable liquid water that ultimately permitted complex living organisms to grow and transform. Over the eons, living things have completely integrated themselves directly into the physical framework of our world. Life has actively remodelled the very shapes of the dry land masses and the deep oceans. Because of this profound connection, the biosphere itself now actively preserves the exact chemical makeup of the atmosphere. This ongoing biological maintenance keeps the protective barrier functional, safeguarding all of our delicate and interconnected ecosystems from destruction. However, this balance will eventually fail as our host star continues its natural life cycle, steadily burning brighter and throwing out more intense heat. This inevitable rise in solar temperature will cause the global climate on Earth to spike dramatically. The extra heat will completely disrupt historic weather cycles, triggering colossal, unprecedented storms that will sweep violently across the globe, while simultaneously causing devastating, catastrophic droughts in other regions. As the plant life across the globe systematically perishes from the extreme conditions, the global supply of oxygen will begin to drop rapidly. Roughly 1 billion years into our future, the grand epoch of complex biological organisms on our planet will definitively come to a permanent end. Earth's atmosphere will ultimately degrade until it mirrors the harsh states of Venus and Mars, turning into a suffocating environment made up almost entirely of carbon dioxide. There will be virtually no other gases left to breathe in the air, and our home will remain trapped in that scorched condition as a baking, oven-like world. This grim state will persist until the sun finally burns through the remainder of its internal hydrogen supplies. When it shifts into its next evolutionary stage, our star will transform into what astronomers classify as a red giant. By studying other aging stars scattered throughout our home galaxy and across the wider universe, we can map out exactly what will happen. Our sun is guaranteed to grow continuously more luminous and searing as time marches forward. During this phase, its outer layers will swell to such a staggering degree that it will expand far enough to nearly consume the entire Earth inside its fiery body. At that catastrophic point in time, the surrounding planets will completely lose their atmospheres, which will be forcefully blown away into the deep cosmos. This colossal expansion happens as the star completely depletes its central repository of hydrogen fuel. The outermost boundary of the Sun swells outwards on a massive scale as our central star officially transitions into its red giant epoch. It will stretch millions of kilometres out into the open void of space. The tiny world of Mercury will be the absolute first planet to be completely swallowed up by the expanding plasma. Shortly after that, the ultimate doom of Venus will be permanently sealed as well. Interestingly, a few advanced computer simulations indicate that Earth might just barely manage to avoid being physically vaporized by this deadly solar expansion. Our planet might continue to exist as a scorched remnant hanging on just past the outer rim of the dying star alongside the orbit of Mars. Even if that happens, the incredibly long-lasting era of the 4 inner rocky planets will be definitively finished. All of the diverse lives that were ever lived out on our beautiful world will amount to nothing more than a faint, forgotten memory lost to time. Shifting our focus to the cold outer edges of the solar system, we encounter Uranus, a planet that unfortunately possesses rather plain and uninteresting cloud decks, if we are being completely honest. Because of this lack of atmospheric variation, there was very little for the onboard cameras to actually capture as they made their close flyby of the world. However, the scientific sensors aboard the Voyager spacecraft quickly exposed the real reason behind Uranus's completely featureless appearance. The temperatures recorded in this distant region are the absolute coldest of any planetary body in our entire solar neighbourhood. There is simply an inadequate amount of internal thermal energy available to spark and sustain the colossal storm systems that we regularly observe on other giants like Jupiter and Saturn. This realization proved that Uranus belongs to an entirely separate category of planetary worlds. It is fundamentally an ice giant. Despite its quiet exterior, the encounter was about to reveal even more unexpected phenomena. Astronomers had already confirmed long before this mission, through careful observations using Earth-bound telescopes, that Uranus possessed a system of rings. We knew for a fact that these rings encircled Uranus, but we lacked any detailed data regarding their specific layouts or their precise shapes. As Voyager began its detailed investigation of the ring architecture, it managed to detect something highly fascinating hidden deep within the dark shadows. It spotted 2 miniature moons, Cordelia, which travels along the innermost boundary of the most prominent ring, and Ophelia, which orbits right along the outermost edge. Together, these small bodies actively maintain the structure of the entire ring system. The individual icy particles making up the rings are constantly corralled, being pushed either further inward or pulled outward by these tiny celestial objects. Because of this behaviour, they are known as shepherd moons. Their localised gravitational influence is strong enough to constantly shape, sharpen and sculpt the rings into distinct, clean lines. Yet it is the highly unusual alignment of these moon orbits, along with the orientation of the rings themselves, that truly sets Uranus apart as the most peculiar world in the solar system. The planet presents a completely inverted profile. Rather than being oriented horizontally like the rings of other worlds, when you view Uranus through a powerful telescope, you see its rings orbiting vertically, travelling straight up and over the poles of the planet. The entire planetary system is completely overturned, mimicking a spinning top that has been knocked over onto its side. This highly irregular tilt strongly indicates that the planet experienced an extraordinarily chaotic history. Ever since the dawn of our solar system, virtually every single object has revolved in one uniform direction. This cosmic motion traces its origins back to a gigantic spinning cloud of interstellar gas and dust that originally circled the newborn Sun. Over vast stretches of time, that rotating material steadily clumped together under gravity, gradually building up each individual planet. In the modern era, they all continue to travel around the Sun and rotate on their internal axes in that exact same counter-clockwise direction inherited from that ancient primordial disk. The only exceptions to this rule are Venus and Uranus, which both rotate in the exact reverse direction. Uranus stands out as uniquely bizarre because the planet's axis is tilted so far that it sits completely on its side. This layout represented a highly unconventional planetary system. So, what exactly caused Uranus to become so severely tilted on its side? If a massive celestial body, roughly equivalent to the size of Earth, collided violently with Uranus during the final stages of its growth history, it would have generated the exact amount of kinetic momentum required to physically upend the planet onto its side. Furthermore, this ancient cataclysmic impact might also provide an answer to another enduring mystery of Uranus, the reason why the planet lacks internal heat. That colossal collision likely ruptured the planet's structure, causing it to bleed out all of the primal internal heat energy that it had trapped inside when it originally coalesced. This energy loss left it behind as a chemically stagnant, sluggish, and relatively inactive world. A wealth of knowledge was gathered during that fleeting space encounter, but Voyager's most baffling planetary revelations were still waiting further out in the dark. The underlying forces that generate weather vary drastically, depending entirely on which part of the solar system you are observing. The behaviour of Earth's atmosphere and the daily weather we experience are powered overwhelmingly by a single dominant force, which is our Sun. The Sun continuously radiates its thermal energy downward through our blanket of air. This radiation strikes the ground directly, causing the solid surface of the Earth to warm up significantly. On Earth, you have all of this incoming solar radiation heating the rocky surface, which in turn generates rising thermal currents that drive the massive atmospheric wind patterns we see globally. In contrast, a world like Saturn does not possess a solid rocky surface that can be warmed by starlight. Therefore, when you look at the meteorological systems operating on these outer gaseous giants and compare them to our own, you have to completely discard your traditional rulebook. While the Sun acts as the ultimate master controller of Earth's climate system, sunlight is a staggering 100 times weaker in the remote territory where Saturn resides. This dramatic drop in solar energy implies that some entirely separate internal heat reservoir must be responsible for driving Saturn's astonishing atmospheric winds. As the Cassini spacecraft carefully monitored the upper cloud systems of Saturn, it allowed scientists to deduce an immense amount of information regarding the highly bizarre interior that must exist far below. It also illuminated the precise energy mechanism that helps fuel this massive planet. The mission carried an extensive array of distinct scientific objectives at Saturn, with an emphasis on deciphering the complex meteorology of the Saturnian atmosphere to find out what exactly accelerates the high-speed winds we observe. Scientists have now definitively validated the hypothesis that the atmospheric systems operating on Saturn are actually being energized from deep below, powered by a potent internal heat source residing within Saturn itself. They are absolutely not driven by incoming solar radiation like the weather systems we experience back on Earth. Peering deep into the hidden layers of the planet exposes an internal heat mechanism that is actively forged by incomprehensible atmospheric pressures. This process unfolds within immense cloud decks made of water vapour, where Cassini managed to document electrical lightning storms that are a staggering 10,000 times more energetic than any lightning strike ever recorded on Earth. This extreme electrical discharge chemically alters the atmospheric methane gas, converting it into massive downpours of solid soot. Descending to a depth of 8,000 kilometers, the crushing weight of the atmosphere reaches an intensity 80 times greater than the pressure found at the very bottom of Earth's deepest oceanic trenches. This extreme environment is fully capable of physically compressing that falling graphite rain, transforming it directly into solid diamonds. Yet, even these diamonds are highly likely to be completely broken down by the even greater pressures deeper within Saturn, eventually melting away completely into a liquid state as they descend 30,000 kilometers down into the core. At this profound depth, Saturn's true thermal engine is finally unveiled. The ambient pressures are so unfathomably high that the hydrogen gas begins to behave like a dense liquid metal that is fully capable of conducting electrical currents. In this exotic state, liquefied helium condenses and falls downward like rain. As this metallic helium rain mixes and sinks into the surrounding planetary material, its kinetic energy is converted and released outward as a massive continuous supply of heat. It is this remarkable internal heat engine that ultimately powers and maintains Saturn's violent weather patterns. Shifting our focus to the search for ancient environments where life could have potentially originated, we find NASA's Mars Reconnaissance Orbiter. This spacecraft, known as MRO, has successfully transmitted more scientific data back to Earth than every other Martian mission in history combined. MERO utilises a suite of 3 specialised onboard cameras. The first of these is the wide-angle weather camera, which scans from one horizon to the other during every single orbit it makes. This constant scanning allows it to construct a complete, updated global map of the entire planet on a daily basis. Because of this, scientists can analyse a fresh global weather map of Mars every single day. The second imaging system is the context camera, which delivers high-resolution imagery and has successfully photographed roughly 99% of the Martian surface. MERO has completed more than 60,000 orbits around the planet, utilising its high-resolution cameras to expose the surface of Mars with completely unprecedented clarity. Its images have revealed massive polar ice avalanches, continuously migrating fields of sand dunes, and highly intriguing seasonal dark streaks that strongly resemble active flows of sand or potentially even liquid meltwater. Then, in the year 2017, MERO redirected its powerful lenses toward one of the absolute oldest geological features on the Red Planet, the deep Eridania Basin, which scientists believe once hosted an ancient, dried-up sea. The Eridania Basin represents a colossal depression located in some of the most ancient crustal rock on Mars. It originally formed roughly 8 billion years ago, and during its prime, it contained a volume of water greater than 10 times the combined capacity of North America's Great Lakes, or roughly 3 times the volume of the Caspian Sea on Earth. Right there, resting on that ancient dried-up seabed, MERO's cameras detected evidence of something truly extraordinary. It identified a massive 400-metre thick mineral deposit that matches the exact chemical signatures of materials created in deep-sea hydrothermal environments, precisely like the mineral mounds found around active volcanic vents on Earth's ocean floors. This discovery proved that Mars did not merely possess the exact same raw chemical ingredients required for life as Earth. It also possessed a highly dynamic, energetic environment capable of sparking those elements into biological action. The Eridania Basin was a fully functioning ancient sea between 3.7 and 3.8 billion years ago, which corresponds precisely to the exact window of geological time when the very first single-celled life was beginning to emerge on Earth. This specific basin might have been a prime habitat where living organisms could have thrived, because those active hydrothermal vents resting beneath that ancient sea would have generated a highly stable chemical-rich environment that was incredibly conducive to life. The early environmental conditions in the formative histories of both worlds appear so remarkably identical that it is entirely logical to conclude that this setup could have easily led to the development of living organisms on Mars. These fertile life-supporting conditions are believed to have persisted in locations like the Eridania Basin for hundreds of millions of years at a time. But then, exactly 7 billion years ago, a catastrophic shift occurred that completely transformed the future prospects for life on Mars forever. Mars experienced a massive, fundamental shift in its global climate system. The entire planet grew significantly colder. Whatever liquid water remained on the surface either seeped deep into the porous ground and froze solid, or turned to ice right on the surface. A massive portion of this water was eventually shifted toward the polar regions, where it accumulated over time to form the massive, thick ice caps that we can still observe through telescopes today. At the exact same time that the global temperatures were dropping to freezing lows, Mars became significantly more volcanically active, which triggered episodes of catastrophic sudden flooding. Colossal volumes of flash floodwaters came raging down from the southern highlands. The water eventually reached a geological feature known as Ecus Chasma, where it plunged violently over massive vertical cliffs 4 kilometers high. This dramatic drop created the most colossal, powerful waterfall that our solar system has ever experienced. The water cascaded down into a spectacular, immense canyon measuring 10 kilometers across and stretching 100 kilometers long. Once these violent flash floods finally ran their course, the water vanished entirely. The absolute only proof that these massive oceans ever existed is etched permanently into the deeply scarred surface of the planet. The radical and violent transformation of Mars from a warm, water-rich sanctuary into a freezing, arid desert remains one of the most sobering warnings in planetary history. As the flash floods dried up, the planet lost its grip on habitability. This complete breakdown of a once hospitable world forces us to look further out into the solar system, where atmospheric extremes present entirely different evolutionary mysteries. Travelling deeper into the outer solar system brings us directly to Neptune, a world characterised by an incredibly vibrant, deep blue coloration. This striking hue is the result of methane gas present in its upper atmosphere, which absorbs red light and reflects a beautiful azure shade back into space. Yet, beneath this serene and tranquil visual exterior lies a planetary environment of pure, unadulterated violence. The atmospheric conditions on Neptune are defined by the most intense supersonic wind systems found anywhere in our entire solar neighbourhood. These massive planetary winds scream across the world at speeds exceeding 2,000 kilometers per hour, which is faster than the speed of sound on Earth. When scientists first looked at the data from the Voyager flyby, they were utterly stunned by the sheer velocity of these winds. According to all traditional rules of physics and meteorology, a planet located so incredibly far from the Sun should not possess the energy required to generate such ferocity. Because Neptune sits 30 times further from the Sun than Earth does, the amount of incoming solar radiation it receives is virtually negligible. It is a world shrouded in perpetual cosmic twilight. This meant that, just like its neighbour Saturn, Neptune had to be generating its own intense internal energy. When astronomers measured the total energy balance of the planet, they discovered that Neptune actually radiates more than twice the amount of energy it receives from the Sun. This immense internal heat source leaks out from the deep core of the planet, rising upward through thousands of kilometers of pressurized gas. As this thermal energy ascends into the freezing void of space, It creates violent convective currents. Because Neptune lacks any solid topography, continents or mountain ranges to break up the flow of moving air, these rising thermal currents encounter zero friction. As a result, the planetary winds accelerate completely unchecked, building up into perpetual, planet-wide superstorms that can easily swallow the entire planet Earth. While the outer gas and ice giants battle these fierce, self-generated internal storms, the rocky worlds situated close to the Sun face a completely different struggle for survival. This brings our attention directly to Mercury, the closest planet to our parent star. For a very long time, Mercury was considered one of the least understood and most difficult worlds to explore. Its extreme proximity to the Sun creates an environment that is incredibly hazardous for robotic spacecraft to navigate. Any vehicle attempting to enter orbit around Mercury must not only withstand the intense, blinding gravitational pull of the Sun, but also the searing, oven-like heat radiated by our star. To overcome these monumental hurdles, engineers designed the Messenger spacecraft, a highly specialised probe equipped with a heavy-duty ceramic heat shield to protect its sensitive instruments. The path chosen for Messenger was a highly complex, winding trajectory that utilised multiple gravitational assists from Earth, Venus and Mercury itself. By performing these precise flybys over the course of several years, the spacecraft systematically shed its immense kinetic velocity, allowing it to safely slow down enough to finally slip into a stable orbit around the tiny, sun-scorched world. Once Messenger established its orbital home, it began to systematically map the heavily cratered surface of Mercury with unprecedented detail. The images revealed a world that looked superficially very similar to our Moon, completely covered in ancient impact scars and vast volcanic plains. However, as the scientific instruments peered closer, they began to detect highly unexpected geological anomalies. One of the most shocking discoveries was the presence of colossal, winding cliffs known as lobate scarps that stretch across hundreds of kilometres of the planet's surface. These massive cliffs rise multiple kilometres into the sky, cutting directly through pre-existing impact craters. When geologists analysed these structures, they realised that they were looking at massive thrust faults. This meant that the entire crust of Mercury had been forcefully compressed and broken apart. The presence of these scarps across the entire globe provided definitive proof of a mind-boggling phenomenon. Mercury is a shrinking planet. As the small world cooled down internally over billions of years, its massive iron core began to solidify and contract. Because the outer rocky crust of the planet is completely rigid, it could not simply shrink smoothly. Instead, as the interior of the planet collapsed inward, the outer crust was forced to wrinkle, crack, and buckle under the immense pressure, creating these giant vertical cliffs. The planet was literally collapsing in on itself, yet the interior of Mercury held an even greater surprise for the scientific community. Despite its small size and incredibly slow rotation rate, Messenger confirmed that Mercury possesses a fully functioning global magnetic field. This discovery completely defied early theoretical models of planetary physics. Conventionally, for a planet to generate a global magnetic shield through a dynamo effect, it requires a rapidly spinning molten metallic core that can generate electrical currents. Because Mercury is so small, scientists assumed its core should have completely frozen solid billions of years ago, which would have permanently deactivated any magnetic dynamo. The fact that Mercury still generates a magnetic field implies that its massive iron core remains partially molten, kept active by a delicate balance of chemical impurities like sulfur that lower the melting point of the metal. While this magnetic field is only about 1% as strong as Earth's, it still serves as a functional protective bubble that deflects the incoming solar wind. This tiny world constantly blasted by the raw fury of the sun, somehow managed to hold on to an active internal engine against all odds. This protective quality of magnetic fields is the absolute cornerstone of Earth's long-term habitability. Our world is blessed with an incredibly powerful, dynamic magnetic shield that is generated deep within our outer core. This liquid iron layer continuously churns and flows around a solid inner core, driven by the planet's rapid 24-hour rotation. This constant motion creates a massive, invisible magnetosphere that extends tens of thousands of kilometers out into space. This magnetic shield acts as a literal shield for our planet, intercepting the relentless stream of highly energetic charged particles thrown out by the sun, known as the solar wind. Without this invisible protective barrier, the high-energy solar particles would slam directly into our upper atmosphere, systematically breaking down water molecules and stripping away the protective gases into the deep vacuum of space over time. The magnetic field is the unsung hero that allowed Earth to preserve its precious oceans for billions of years, creating the stable cradle required for complex life to evolve. The absolute tragedy of Mars is that it once possessed this exact same protective mechanism but lost it entirely. During the first few 100 million years of its history, Mars was a vibrant, geologically active world with a molten core that generated a powerful global magnetic field. This allowed the young red planet to maintain a thick, insulating atmosphere and support vast lakes and seas of liquid surface water, such as those found in the Eridania Basin. However, because Mars is significantly smaller than Earth, possessing only about 11% of Earth's total mass, it suffered from a fatal geometric disadvantage. Smaller planetary bodies possess a much higher surface area to volume ratio, which means they lose their internal heat energy to the cold vacuum of space at a much faster rate than larger worlds. As the interior of Mars steadily cooled down, the convective currents within its core began to slow down and eventually ceased entirely. With the internal engine turned off, the Martian global dynamo collapsed, and its protective magnetic shield completely vanished. Once the magnetic barrier was down, Mars was left totally defenceless against the raw power of the solar wind. Over the course of hundreds of millions of years, the solar wind stripped away the Martian atmosphere, molecule by molecule, permanently destroying its greenhouse effect and dooming the world to a frozen, sterile existence. The sudden collapse of Mars's global shield sealed its cold and dusty fate, leaving its surface totally scarred and barren. This dynamic reminds us that the planetary objects in our solar neighbourhood are constantly at the mercy of massive structural forces. Looking elsewhere in our solar neighbourhood reveals another world experiencing a different kind of extreme structural destruction. We must travel to the spectacular gas giant Saturn to witness this phenomenon. Long ago, Saturn possessed an additional distinct moon orbiting around it. This ancient celestial object measured roughly 400 kilometers across from edge to edge. The entire body of this lost moon was composed completely of pure ice, even though it was a substantial frozen world. This celestial body was ultimately doomed to a violent end. It happened because the moon's historical path brought it much too close to the gas giant. It was travelling in a dangerous zone where it could no longer withstand the immense, crushing gravitational pull of Saturn's body. When we observe Saturn's iconic rings today, they tell the story of a world that ventured too close to the planet. There is a very specific, invisible boundary that encircles the gas giant, which scientists refer to as the Roche limit. This boundary represents a critical threshold in open space, and its exact distance changes depending on the specific chemical materials an object is made of. Once an object crosses this threshold, Saturn's natural gravitational pull becomes so incredibly intense that it will physically pull the approaching object completely apart. This destruction happens because the gravitational force pulling on the near side of the Moon facing Saturn is vastly stronger than the force pulling on the far side. The difference between these two forces creates an immense stretching effect that will literally rip the object to pieces. In this dangerous zone, the approaching Moon simply does not possess enough of its own internal gravity to hold its structural body together. According to the leading scientific theory, an icy moon crept closer to the upper layers of Saturn's atmosphere. The small frozen world slowly drifted right up to, or potentially crossed just inside, this critical Roche limit. As soon as it entered this space, the staggering gravitational forces of Saturn began to tear the moon apart in a sudden catastrophe. The icy crust and core began to shatter and rupture violently. This was a massive frozen world being completely broken down by its close proximity to a gas giant. A staggering volume of material, weighing up to 17,000 trillion tons of pure ice, was completely shattered while in orbit around Saturn. Because this debris was travelling at incredibly high velocities. The shattered remains did not fall into the planet. Instead, over the course of just a few short days, the ice fragments spread out completely around the equator, encircling the giant planet like a massive highway of debris. This violent event is exactly how Saturn's world-famous ring system was originally established. For a long time, we could only observe these rings from a great distance. But when the automated Cassini spacecraft finally reached Saturn and aimed its advanced scientific instruments directly at the rings, it revealed a structure that had been completely transformed over time. The high-resolution images sent back by the probe were absolutely phenomenal. The level of visual detail was a factor of roughly 20 times sharper than any photograph humanity had ever captured before. The data from Cassini exposed exactly how these colossal rings have changed and evolved over long stretches of history. The ancient icy debris now forms a colossal flat disk that is actually wider than the giant planet Jupiter. Yet, despite this incredible width, the disk is surprisingly paper thin, measuring on average a mere 10 meters in thickness from top to bottom. Moving within this thin sheet of debris are massive moon-sized chunks of solid ice that continuously orbit the planet. As these larger icy bodies travel, their gravity systematically clears out open lanes and voids in the debris, transforming what looked like a single solid ring into many individual bands. The most surprising feature of this ring architecture emerged when Cassini captured images during a specific orbital phase. The Sun was positioned directly above the planet's equator, casting long shadows across the system. Scientists knew this specific geometry would provide a unique opportunity to explore the third dimension of the rings. This vertical dimension is something you completely miss when you just look at a standard flat photograph of Saturn. What the team discovered left them completely staggered. Right from the very beginning of this observation phase, the cameras recorded massive vertical structures rising out of the flat plane. The scientists were utterly surprised to see these giant features. The sheer grandeur and visual spectacle of the scene was completely unanticipated by any theoretical models. It sparks the imagination to picture yourself piloting a small spacecraft along the edge of the rings. From that close perspective, the ring system would look like an endless gleaming desert of reflecting icy rubble. You could fly along this flat sheet of debris for vast distances, completely undisturbed. Then, completely out of nowhere, you would come face to face with a towering wall of icy rubble that rises 2 miles straight up into space. It is an incredibly spectacular sight that seems like it belongs in a science fiction movie. This magnificent structure, formed from a single tiny world of shattered rock and ice, has undergone a dramatic transformation to become the most beautiful jewel in our solar system today. After spending more than a decade orbiting the gas giant, the Cassini mission permanently expanded our understanding of Saturn and its complex environment. However, our exploration of the solar system's deep history must go back even further to the dawn of the planets. We must examine the early history of the giant planet Jupiter as it circled our young Sun. During its initial formation, the young Jupiter began to clear out a wide path through the massive cloud of gas and dust that enveloped the early solar system. But as the baby planet ploughed through this material, it began to do something incredibly alarming. Jupiter began to spiral directly inward toward the Sun, moving like a massive cosmic bulldozer. It marched straight through the pristine region of space that would later become our modern asteroid belt. When the giant young Jupiter moved aggressively through this primordial asteroid belt, the entire region was thrown into total chaos. Rocky materials were scattered in all directions and violently deflected by the planet's immense gravity. As a direct consequence of this intense gravitational bullying, more than 99% of the original rocky mass that existed in that zone was completely eradicated and thrown out. The ancient asteroid belt was fundamentally disrupted and thinned out by the migrations of the giant worlds. This movement acted to forcefully throw rocky material out of its native orbit, casting it into the deep outer solar system. Because of this severe lack of remaining material, small protoplanetary cores like the dwarf planet Ceres were never able to gather enough mass to graduate into full-fledged rocky planets. There was simply not enough building material left in their orbital neighbourhood. When Jupiter marched through that ancient asteroid belt, it completely starved Ceres of the matter it needed to grow. This intervention halted the dwarf planet's growth permanently, condemning it to spend the rest of its history as a small, frozen and barren rock. But Ceres was not the only world in our solar system whose development was permanently cut short by this cosmic migration. The planet Mars would eventually suffer an incredibly similar fate at the hands of Jupiter. After marauding through the asteroid belt, Jupiter continued its inward journey. It entered the exact region of space where the young Mars was actively trying to form. Jupiter kept spiralling closer and closer to the Sun, as Jupiter bulldozed its way into the inner solar system. Its immense gravitational field scattered planetary building blocks everywhere. Some of this material was sent careening directly into the Sun, while other massive fragments were flung completely out into the freezing void of interstellar space. It is precisely because of this aggressive gravitational clearing of the neighbourhood by Jupiter that Mars was starved of material. The red planet was never able to grow to more than 10% of the total mass of the Earth. This ancient interruption is the true reason why Mars remains so small today. Furthermore, by clearing all of this rocky material out of the inner solar system, the giant planet also prevented the formation of massive super-Earths like the ones we regularly observe in other star systems. If Jupiter had continued its inward march toward our star, our own planet Earth might never have been able to form at all. But just as it looked like Jupiter would completely sweep away the entire inner solar system, the giant planet suddenly stopped right in its tracks. This dramatic halt occurred because another massive planet was forming out in the deep shadows of the outer solar system. This was the solar system's second largest gas giant, Saturn. The arrival of Saturn changed the dynamics of the entire system. As Jupiter moved inward, the newly formed Saturn also began to spiral inward, quickly catching up to Jupiter's orbit. When the two giants got close enough, their orbits locked into a highly stable, unique configuration known as a mean motion resonance. In this configuration, the two worlds began to interact gravitationally in a perfectly synchronized, coherent manner. Locked together as a single gravitational unit, the two planets completely reversed their migration path. Instead of spiralling toward the Sun, they began to move back out into the outer solar system. Saturn effectively forced the giant Jupiter to retreat. This outbound movement left behind a small, preserved remnant of rocky material from which the inner terrestrial planets could safely form. This remaining material allowed for the birth of Mercury, Venus, and our own home world. Earth ended up forming in the exact right location to provide a stable, long-term environment where life could successfully develop. If Jupiter had moved around just a little bit differently during that ancient era, who knows what would have happened? It is highly likely that life never would have emerged in the solar system as we know it today. As this grand ancient voyage across the solar system drew to a close, Jupiter helped provide our living world with its most vital and precious ingredient. Today, roughly 2/3 of our planet's surface is completely covered by deep oceans. This amounts to more than 3 billion cubic kilometres of liquid water, with every single drop teeming with biological life. One of the absolute greatest questions regarding the evolution of our solar system is how we managed to get so much water onto this rocky planet. Scientists believe that the inner planets did not naturally form with a large amount of water because the inner solar system was too hot. Liquid water and ice were primarily restricted to the cold outer regions of the solar system. But because Jupiter and Saturn reversed course and moved outwards together, their migration was able to suddenly deliver vast amounts of water into the inner solar system. While locked in their gravitational dance, Jupiter moved back out through the asteroid belt. As it ploughed through the belt a second time, it flung water-rich asteroids and comets inward toward the Sun. This icy material was incorporated directly into the growing bodies of the rocky inner worlds. Therefore, the complex movements of the giant planets played an essential role in delivering life, giving water to our region of space. In a very real sense, we have to thank Jupiter's outward march through the asteroid belt for delivering the water that fills the oceans of the Earth. Our planet would be a completely different dry world if not for Jupiter's ancient primordial dance. Roughly 100 million years ago, another major gravitational event occurred. A massive asteroid, measuring 10 kilometers across, was violently ejected from the asteroid belt. It was dislodged from its stable home orbit by the subtle gravitational nudges of Jupiter. This massive rock was sent on a direct, unalterable collision course with Earth. When that asteroid finally struck our planet, the impact generated an incomprehensibly hot fireball. Anything living within a 1,000 kilometre radius of the impact site was instantly vaporized and killed. The colossal impact threw roughly 300 billion tons of pulverized sulfur straight up into the global atmosphere. During the prolonged nuclear winter that followed this event, 75% of all living species on Earth were completely wiped out. Both plant and animal life across the globe perished, including the largest creatures to ever walk upon the surface of our world. By driving the dinosaurs to total extinction, Jupiter's gravitational nudge cleared the evolutionary path for mammals, and eventually humans, to inherit the planet. Although Jupiter still occasionally flings stray asteroids toward the inner solar system, the giant planet also acts as our ultimate protector. For dangerous objects that come racing toward Earth from the frozen outer edges of the solar system, the giant planet's immense gravity acts as a literal shield.